All right, welcome to This Explainer. Today, we're diving into what I like to call the Kubernetes Conundrum. So I want you to just imagine for a second that we're grabbing a coffee together, okay? I'll be playing the role of the senior mentor, you're the eager new engineer on my team, and we're sitting down to have a very real, very frank chat about our infrastructure. You see, there's this pattern that happens constantly in software engineering, and it centers around one massive buzzword. We're going to unpack this conundrum today, specifically looking at the absolute critical difference between complexity that is earned and complexity that's just assumed. All right, let's get into it.
So picture this scenario. You join a new team. You spend that entire first week just getting your environment set up, right? Downloading repos, messing with access keys, the whole shebang. And then, inevitably, you ask this exact default question. Hey, are we using Kubernetes? And honestly, if the answer is yes, your brain probably goes, oh, cool, respect. But if the answer is no, your immediate follow-up thought is almost always, wait, why not? It just feels like Kubernetes is the obvious default. Like if you're using anything else, your team is somehow stuck in the dark ages.
Now listen, I want to completely validate that feeling. It is not a bad instinct at all. I mean, Kubernetes is literally everywhere. It dominates job postings, it's the subject of every other conference talk, and it's all over those LinkedIn flex posts. But as your senior engineer in this scenario, I'm here to tell you that this instinct, it's actually slightly off. By defaulting straight to Kubernetes, we're skipping a really crucial engineering step. And understanding why this default mindset is a trap is going to permanently change how you approach infrastructure from here on out.
To really get why, we need to completely reframe this tool and define the actual problem it solves. Okay, so it's a container orchestration platform, but look closely at that definition. It answers a very, very specific question. How do I run many containers across many machines reliably? Notice how it doesn't just ask, how do I run containers, or how do I deploy my app? No, that many times reliably part, that is the whole point. That massive scale and strict reliability requirement is the entire foundation of why Kubernetes even exists.
Because when you actually have massive scale requirements, Kubernetes steps up and does some absolutely incredible heavy lifting. I mean, look at the insanely hard problems it solves. It schedules containers onto available nodes, it automatically restarts containers that randomly crash in the middle of the night, it scales your pods up and down dynamically based on user load, handles flawless zero downtime rollouts, balances traffic, manages all your secrets. It's a beast. So the crucial takeaway here is this. When you're operating dozens of services across multiple nodes, getting hit with crazy unpredictable traffic spikes, and you've got incredibly strict uptime SLAs, well, these features make Kubernetes worth its weight in gold. It's a lifesaver for genuinely painful operational problems.
But, and this is a massive structural but we really need to talk about, Kubernetes adds real complexity. I literally cannot stress this enough to you. This isn't your standard, oh, I'll just get the hang of it this weekend by watching a YouTube tutorial kind of complexity. Adopting Kubernetes is a massive structural commitment. It fundamentally changes the day-to-day reality of your entire engineering org.
Because suddenly you have to manage a control plane or pay a huge premium for someone else to do it. Networking isn't just opening a port anymore, it becomes its own intense discipline with CNI plugins, ingress controllers, and service meshes. Storage isn't just saving a file to a disk, it's this whole wild world of persistent volumes and dynamic provisioning. Security, now you're dealing with layers of RBAC and insanely complex network policies. And debugging, oh man, debugging gets substantially harder. Seriously, every single engineer who has operated Kubernetes in production has a war story. It's the 2 days spent agonizing over why a pod wouldn't schedule, only to realize it was node affinity taints. It's waking up in a cold sweat to a 3 a.m. alert because of some bizarre eviction policy misconfiguration, or, the classic developer punchline, spending 6 hours investigating a total system outage, only to realize it was just DNS. Now, none of this means you should avoid Kubernetes entirely, but it is absolutely essential context before you make the leap.
To really bring this home, let's compare two totally different worlds. Take the Type 1 team. Now, these are the teams that genuinely need Kubernetes. They're a huge organization, they're running 10+ services, and multiple teams are deploying totally independently. Their traffic goes crazy, like 10x spikes between off-peak and peak hours. They have super strict uptime SLAs, and crucially, they have a dedicated platform team just to babysit the cluster. For them, that complexity cost, totally justified. Now contrast that with the Type 2 team. Honestly, this is most teams. A small group, maybe 5 engineers. They have 3 services, and let's be real, one of those is basically just a giant monolith. They have predictable, modest traffic and absolutely zero dedicated infrastructure folks. But they think they need Kubernetes because, well, it looks good on a resume, or it feels like the grown-up choice. And the result? They take on massive, crushing complexity for a tiny fraction of the benefit. Deployments become a total nightmare. Onboarding a new engineer takes twice as long. And that monolith, it now has a Helm chart that literally nobody on the team fully understands.
And then, well, then there is the Type 3 team. The CTO read a blog post. I honestly don't even need to explain this one further, right? We've all seen it, and we can all share a deep, empathetic sigh over it. The engineers didn't choose Kubernetes based on their actual needs. It was chosen for them by a non-technical leader chasing a shiny industry buzzword. And now, unfortunately, those poor engineers are just stuck maintaining it.
So back to our coffee chat. As your mentor, how do I actually want you to approach this? We need a Socratic turning point here. We are completely tossing out your original question. Instead, this is the actual question a senior engineer uses to evaluate architecture. What specific problems are we trying to solve, and what is the simplest tool that solves them? Do you see the shift there? We aren't asking if our team is, quote-unquote, advanced enough for Kubernetes. We're treating infrastructure like an actual engineering problem, not a fashion trend.
Because if your answer to that previous question was basically just, well, we want to use containers, there are so many simpler, better paths. For small apps with predictable load, good old Docker and Compose on a single VM works beautifully. It's simple, it's debuggable, and it's dirt cheap. Or say you want managed container orchestration, but you don't want the absolute nightmare of running your own control plane, AWS ECS or Fargate are fantastic for that. What if you need serverless containers where you just hand over an image and it magically auto-scales without a cluster in sight? Google Cloud Run or AWS App Runner will be your best friends. Or if you just want to hand off the infrastructure entirely so you can focus 100% on your app's logic, PaaS platforms like Render or Fly.io are incredible. And please hear me on this. Absolutely none of these alternatives are somehow less professional than Kubernetes. They are just highly capable tools with different trade-off profiles. Picking the right tool for the actual problem sitting in front of you, that is the entire job of a senior engineer.
And that brings us right to the core heartbeat of today's explainer. We constantly have to weigh this balance. Complex systems are perfectly fine, but only if they are earned through genuine operational needs. We're talking multi-service orchestration at massive scale, fully independent team deployments, wild auto-scaling requirements. If you have those, yes, Kubernetes is a very serious candidate. But on the flip side, we have complexity assumed. That's taking on this massive mountain of overhead just because you want to use containers or because you're doing some resume-driven development. Listen, complexity must be earned through necessity. It should never, ever be merely assumed as the default.
So let's wrap this up with one really powerful framing shift. The junior engineer walks into the room and asks, are we using Kubernetes? But the senior engineer, they step back, they look at the actual operational problems the business is facing, and they ask, should we? That one single shift in framing is worth its weight in gold. It will protect your team's time, your sanity, and your operational budget. So the next time you go to reach for the biggest, shiniest, most complex tool on the market, I want to leave you with this provocative thought. Are you actually solving a problem, or are you just buying yourself a completely new one? Thanks for hanging out with me for this explainer, and remember, keep asking the right questions.